Hi everyone, you are watching the MyBrain Learning channel. Our topic for today is about the Pythagorean Theorem. It is named after the famous mathematician and philosopher Pythagoras, of ancient Greece, who was born at the time of 570 BC. Before we proceed with the topics, and if you are new to this channel, please don't forget to click the like button, subscribe button and notification bell to keep you updated on the new videos in the future episodes. The word theorem refers to a mathematical statement supported by different proofs and explanations based on factual examples. Pythagorean theorem is applicable for solving right triangles. At the end of the topics on Pythagorean theorem, we will proceed to the solutions to quizzes on the previous episode of trigonometry. The formula of Pythagorean theorem is c squared is equal to a squared plus b squared, where c is the hypotenuse or the longest side of the right triangle while a is the opposite side to angle A and b is the adjacent side of angle A. As a simple proof, the length of the hypotenuse of the right triangle may be represented by a square with equal sides each has the value of c. When two of the equal sides c are multiplied, it will become c squared. Furthermore, this will also be the same when a square having the same length a as the opposite side multiplied by itself will be equal to a squared. Moreover, the same length b as the adjacent side multiplied by itself will be equal to b squared. Assuming that each surface of plywoods a and b have a certain distributed liters of paint, this will also be exactly the same for plywood c. Therefore, c squared is equal to a squared plus b squared. To solve the value of the hypotenuse c using the Pythagorean theorem, simply get the square root of both sides of the equation. Thus, the formula will now become c is equal to the square root of the sum of a squared and b squared. Let us have an example. As shown in the drawing, the height of the building A is equal to 200 feet and a 350 feet distance of the solar panel from the base of the building. Since c is the unknown diagonal distance from the solar panel to the top of the building, the equation will be c squared is equal to the quantity of 200 feet squared plus the quantity of 350 feet squared. Squaring both substituted values, c squared is equal to 40,000 feet squared plus 122,500 feet squared. Adding the squared values, c squared is now equal to 162,500 feet squared. Squaring both sides of the equation, the diagonal distance from the solar panel to the top of the building is equal to 403.11 feet. To solve the value of the opposite side, subtract the square of the value of adjacent side from the square of the value of hypotenuse, then square both sides of the equation. Thus, the formula will become a is equal to the square root of c squared minus b squared. For example, find the height of the helicopter from the level of roof deck if the diagonal distance is 100 feet and a horizontal distance of 30 feet. Substituting the values, the equation will now become quantity of 100 feet squared is equal to a squared plus quantity of 30 feet squared. To find the value of a, subtract quantity of 30 feet squared from quantity 100 feet squared, then rearrange the equation from left to right. Thus, a squared is equal to quantity of 100 feet squared minus quantity of 30 feet squared. Squaring both substituted values, a squared is now equal to 10,000 feet squared minus 900 feet squared. Furthermore, a squared is equal to 9,100 feet squared. Moreover, a is equal to square root of 9,100 feet squared. Therefore, the height of the helicopter from the level of roof deck is equal to 95.39 feet. To find the value of the adjacent side, subtract the square of the value of opposite side from the square of the value of hypotenuse, then square both sides of the equation. Thus, the formula will become b is equal to square root of c squared minus a squared. For example, the height of the tree stem is 15 feet where the 20 feet ladder is to be leaned. Find the distance of the foot of the ladder to the base of the tree. Substituting the values, the equation will become the quantity of 20 feet squared is equal to the quantity of 15 feet squared plus b squared. To find the value of b, subtract the quantity of 15 feet squared from the quantity of 20 feet squared, then rearrange the equation from left to right. Thus, b squared is equal to the quantity of 20 feet squared minus the quantity of 15 feet squared. Squaring the substituted values, b squared is now equal to 400 feet square minus 225 feet square. Thus, b squared is equal to 175 feet square. Squaring both sides of the equation, b is equal to the square root of 175 feet square. Therefore, the distance from the foot of the ladder to the base of the tree is equal to 13.23 feet. Let us now have some sample word problems on Pythagorean theorem. In our first example, what is the length of the ladder needed by the painter if the wall is 12 feet high and its base is 3 feet from the bottom of the aforementioned ladder? As shown in the illustration, the height of the wall where the ladder is to be leaned on is 12 feet while the distance of the foot of the ladder from the base of the wall is 3 feet. To start solving the unknown length of the ladder, substitute the value of a and b to the Pythagorean formula c squared equals a squared plus b squared. Thus, c squared is equal to the quantity of 12 feet squared plus the quantity of 3 feet squared. To get the squared quantities, multiply both 12 feet and 3 feet by themselves. The equation will now become c squared is equal to 144 feet square plus 9 feet square. Furthermore, c squared is equal to 153 feet squared. Squaring both sides of the equation, c is equal to the square root of 153 feet square. Therefore, the length of the ladder will be c is equal to 12.36 feet. In our second example of the Pythagorean theorem word problem, find the height of the cylinder if the longest diagonal distance from top to bottom is 32 inches having a diameter of 22 inches. As shown in the figure, the hypotenuse is equal to 32 inches while the diameter of the cylinder is 22 inches. To start solving the unknown height of the cylinder, substitute the values of hypotenuse c and the diameter b to the Pythagorean formula. Thus, the equation will now become the quantity of 32 inches squared is equal to a squared plus the quantity of 22 inches squared. To start solving the height of the cylinder, subtract the quantity of 22 inches squared from the quantity of 32 inches squared by transposing to the other side of the equation, then rearrange it from left to right. Thus, the equation will now become a square equal to the quantity of 32 inches squared minus the quantity of 22 inches squared. To get the squared quantities, multiply both 32 inches and 22 inches by themselves. The equation will now become a square is equal to 1024 inches square minus 484 inches square. Furthermore, a square is equal to 540 inches square. To find the value of a, square both sides of the equation. Therefore, the height of the cylinder will be equal to 23.24 inches. In our last sample problem on Pythagorean theorem, find the distance of the restaurant from the school building if its base has a diagonal distance of 70 feet to the rooftop of the school building that has a height of 30 feet. As shown in the drawing, the distance from the base of the restaurant to the rooftop of the school building is equal to 70 feet while the height of the school building is 30 feet. To start solving the distance of the restaurant from the school building, substitute the values of hypotenuse c and the height a to the Pythagorean formula. Thus, the equation will now become, quantity of 70 feet squared is equal to quantity of 30 feet squared plus b square. Furthermore, subtract the quantity of 30 feet squared from the quantity of 70 feet squared by transposing it to the other side of the equation, then rearrange it from left to right. The equation will now become b square is equal to quantity of 70 feet squared minus quantity of 30 feet squared. To get the squared quantities, multiply both 70 feet and 30 feet by themselves. The equation will now become b square is equal to 4,900 feet square minus 900 feet square. Moreover, b square is then equal to 4,000 feet square. To find the value of b, square both sides of the equation. Therefore, the distance of the restaurant from the school building is equal to 63.2 feet. Let us now proceed to the solutions to quizzes in our previous episodes on trigonometry. In quiz number 1, find the altitude that the eagle needs to reach if the horizontal distance of the rabbit to be grabbed is 3 kilometers away. The angle of elevation from the back of the rabbit to the line of sight of the eagle is 42 degrees with respect to the ground. Let us draw as stated in the problem. The horizontal distance AC from the eagle to the rabbit is equal to 3 kilometers with a line of sight from the rabbit to the eagle having an angle of elevation of 42 degrees. Since the unknown height of the eagle from the ground is BC, the equation will be tangent 42 degrees is equal to BC divided by AC. Thus, tangent 42 degrees is equal to BC divided by 3 kilometers. To solve the value of BC, multiply 3 kilometers by tangent 42 degrees. Using the scientific calculator, tangent 42 degrees is equal to 0.9. Thus, BC is equal to 3 kilometers times 0.9. Therefore, the altitude of the eagle from the ground BC is equal to 2.7 kilometers. In quiz number 2, find the length of the chain with an angle of 41 degrees from the wooden drawbridge of the medieval castle if the height of the entrance is 60 feet from the floor. As shown in the illustration, the unknown length of the chain is AB with an angle of 41 degrees while BC is the 60 feet height of the entrance from the ground. Thus, the formula is sin 41 degrees is equal to BC divided by AB. Furthermore, sin 41 degrees is equal to 60 feet divided by AB. To find the value of AB, divide 60 feet by sin 41 degrees. Using the scientific calculator, sin 41 degrees is equal to 0.656. Therefore, the length AB of the chain is equal to 91.46 feet. In quiz number 3, what is the length of rope needed for the flagpole if it has an angle of 62 degrees with respect to the ground and to be tied 5 meters away from the flagpole? As shown in the drawing, AC is the distance of the flagpole from where the rope is to be tied on the ground having an angle of elevation of 62 degrees. Since the unknown length of the rope from the flag to the point in ground where to be tied is AB, the equation is cosine theta is equal to AC divided by AB. Thus, cosine 62 degrees is equal to 5 meters divided by AB. To find the value of AB, simply divide 5 meters by cosine 62 degrees. Using the scientific calculator, cosine 62 degrees is equal to 0.469. Furthermore, AB is equal to 5 meters divided by 0.469. Therefore, the length AB of the rope needed for the flagpole is equal to 10.66 meters. What are your thoughts on the topics discussed today? Feel free to ask and let us know in the comments section below. If you enjoyed watching this video, please don't forget to click the like button and subscribe button as well as sharing this to your friends. You can also click the notification bell to keep you updated on the new videos to watch. Thank you so much for watching. This has been the MyBrain Learning channel and see you in the next episode.